Hello everyone. First and foremost, I would like to thank Department of Physics and Dr. C.P. Khatiwala sir of Namchi Government College and Sikkim University for providing me such a platform for partial fulfillment of BSc Honors on Physics at 5th SEM. My name is Diwakar Rai and my roll number is 18NS0016. My topic is SR flip-flop and D flip-flop. Let's start my topic. Now we're going to learn about SR flip-flop. Firstly, flip-flop is a memory element which is capable of storing one bit of information in a closed sequential circuit. Most simple type of flip-flop is SR flip-flop, or SR flip-flop is considered as one of the most simple flip-flop. SR flip-flop is also called set-reset flip-flop. SR flip-flop is designed either by two cross-coupled NOR gates or two cross-coupled NAND gates. Now we're going to learn about SR flip-flop using NAND gate. This diagram is called logic diagram of SR flip-flop. S and R are the two input, S stands for set, R stands for reset. And Q and Q bar are the two outputs. They are complement with each other. So there is two condition. The circuit will be in set when Q is equals to 1, or similarly circuit will be in reset when Q is equals to 0. This section is called SR latch. Here to the SR latch we have connected two NAND gates and one clock signal to form SR flip-flop. So to understand the SR flip-flop, first we should have knowledge about NAND gate operation and SR latch. So these are the two truth tables for NAND gate and SR latch. If you observe truth table of NAND gate, we will find if any input of NAND gate is 0, then its output will be 1. Similarly, if the two inputs of NAND gate is 1, its output is 0. By understanding these two, we can understand the working of SR flip-flop. By understanding the operation of SR flip-flop, we can write the truth table. So here is the truth table for SR flip-flop. If we take clock signal as 0, irrespective of what we have at this input, output of these two NAND gate will be 1 and 1. This 1 and 1 is the input for SR latch. If 1 and 1 is the input for SR latch, memory will be the output of SR latch. So here, if we take clock signal as 0, S and R as don't care, we'll get memory as output. Similarly, if we take clock signal as 1, S and R as 0, for 0 1, output of NAND gate will be 1. For 0 1, output of NAND gate will be 1. Similarly, for 1 0, NAND gates of output of NAND gate will be 1. For 1 0, output of NAND gate will be 1. So this 1 and 1 is the input of SR latch. If 1 and 1 is the input of SR latch. Memory will be the output of SR latch. So here we have taken clock signal S1, SS0, RS0. The memory will be the output of SR latch. Similarly, it goes on. Now here, if we take clock signal S1 and S and R S1, will get the invalid state. When S is equal to 1 or R is equal to 1, this combination is called restricted combination, which is referred to as invalid state. This invalid state is the main or major drawbacks of SR flip-flop. Hello everyone. First and foremost, I would like to thank Department of Physics and Dr. C.P. Khatiwala sir of Namchi Government College and Sikkim University for providing me such a platform for partial fulfillment of BSc Honours on Physics at 5th Sem. My name is Diwakar Rai and my roll number is 18NS0016. Now we are going to learn about D flip-flop. D flip-flop is also called data flip-flop. It is a modified set-reset flip-flop with the additions of an inverter to prevent S and R input from being at same logic level. This means D flip-flop is used to prevent or eliminate invalid state of SR flip-flop. D flip-flop is also called data flip-flop because it is used to give stored data. D flip-flop is considered one of the most important flip-flop because it ensures that the two inputs never equals at the same time. Now, in order to understand the D flip-flop, first we should have knowledge about SR flip-flop and its truth table. This portion is called logic diagram of SR flip-flop, and this is the truth table of SR flip-flop. D flip-flop is obtained from SR flip-flop by combining two input S and R. We can make one input D by combining both input S and R. Here we have connected NOT gate between S and R. It means if we give 1 here, this input becomes 0. Similarly, if we give 0 here, this input becomes 1. This means S and R inputs are complement with each other. In D flip-flop, we can obtain these three combinations. But we cannot obtain these two combinations because the two input S and R are equal or they are not complement with each other. That is why these two inputs are not obtained from this combination. So here is the truth table for D flip-flop. We know that S and R inputs are combined to form one input, that is D. This means input S and R are equal to D. So if we take clock S0 and SR or DS, don't care, we'll get memory as output. Similarly, if we take one clock S1 and DS0, we'll get 0 as output. This is how The D flip-flop is used to eliminate invalid state of SR flip-flop.